Thank you so much for joining me today on a tour of ISTIO Ambient Service Mesh. How many of you have heard the project ISTIO? Great. How many of you know Service Mesh? Awesome. All right, just a little bit introduction about me. I work for Solo. I joined Solo about 2 years ago. I just actually hit my 2-year anniversary at Solo. I used to work at IBM. IBM was a co-founder of the ISTIO project. So I've been working on the ISTIO project since the beginning of the project. I've been one of the founding technical oversight committee member and also the steering committee member. I wrote 2 books about ISTIO, which we will have a book signing session right after this talk about my new book, ISTIO Ambient Explained. I'm also a CNCF ambassador. If you were, how many of you were in the talk before this one, talk about open telemetry? Right, so they talk about CNCF ambassador on the first row. That was me. I've done a lot of innovations while I was at IBM. So I had 207 IBM patents. I took that screenshot the moment I left IBM because I no longer have access to the fancy IBM system after I leave. I also run a live stream about technologies, particularly around cloud native and service mesh. How many of you know our company, Solo.io? Okay, it's a small startup company. When I joined Solo, it's only 30 people. Right now, we have about 200 people. It was founded by Edith Levine, who is my boss. And we just had a recent Series C fund, which we had $1 billion valuation. So that's a small introduction about our company. We focus on application networking, and we have a commercial product called Glue Application Network Platform. What we are passionate at Solo is education. We want to educate people in the cloud native space. So we have a Solo Academy. So if you're interested in hands-on workshop, and that's totally free, where we provide an environment, and you can, get educated on ISTIO, Envoy, eBPF. So that's what Solo Academy is. So for folks, since some of you are not familiar with service mesh, what exactly is a service mesh? It's a programmable framework that allows you to observe, connect, and secure your microservices, right? Some of you were in the talk before me, Eric talked about open telemetry, how you can use library to instrument your application. With service mesh, we're providing a consistent way to help you observe, connect, and secure your microservices without needing to add in libraries to your applications. So when we first started service mesh a couple of years ago in the industry, we were using this technology called sidecar, which means, by the way, I'm dragging my luggage, so you can imagine me walking, dragging my luggage. But with sidecar, it's more your application dragging a particular luggage with your application. That's what we call sidecar. It's typically implemented using Envoy proxy. What's nice about the sidecar technology is instead of your application figure out how to do telemetry, how to do secure communication, how to handle resiliency and failures in the distributed network, the sidecar proxy take care of all that for you. And what's even interesting is the sidecar technology took care of for you in a language agnostic way. And without you need to worry about it inside of your application. So typically, there is a service mesh control plane that programs the sidecar to do what you want to do, depends on the policy you apply to the control plane. Last year, there has been an evolution in the service mesh industry where we start to focus on, what if I don't want to drag that luggage with my application all the time? What if I just want to focus on my application and I can still get all the benefits from the service mesh, such as connect, secure, and observe, without the sidecar. So in the ISTIO project, we started the evolution of ISTIO Ambient service mesh, which introduced a new data plane mode without you as a developer, as an operator, needing to drag the sidecar with you. So that is the evolution we're going to focus on today. Just quickly about ISTIO, it's the industry's leading service mesh. It's the most deployed service mesh in production today. ISTIO was launched in 2017, and I was part of the IBM team back then. Envoy, it was the ISTIO's data plane proxy since the beginning of the project. I believe Envoy made a lot of enhancement. It's a CNCF graduation project. It still was very widely adopted since ISTIO, I believe 1.1 was people starts to adopt ISTIO. 1.5 is when we introduced simplified control plane. We start to see more and more customers adopt ISTIO. Last year, ISTIO made to CNCF as an incubation project, and we also launched ISTIO Ambient Service Mesh, which is the new data plane mode, enables you to run your application without sidecar, but continue to enjoy the benefits that's brought to you for service mesh. So Google and Google and Solo actually worked on ISTIO Ambient Service Mesh as a partnership before the launch. So the project is focused on, the number one goal is without sidecar, right? As part of the benefit of without running the sidecar is simplify operation, reduce your cost, and also improve performance. So what does that mean, right? So without the sidecar, you think about it, right? Envoy comes out a CVE almost every single quarter, likely every month, but definitely every single quarter. What does it mean if you are running a sidecar? That means you have to restart your application to pick up the new CVE from Envoy if you want to be concurrent, if you want your security tool doesn't complain about CVEs, right? So without running the sidecar, it really simplifies your onboarding experience. It simplifies the maintenance experience for your application because you no longer need to restart your application to pick up that new CVE from Envoy proxy. Reduce cost, we do expect to reduce cost dramatically. The reason being is a lot of people adopt a service mesh maybe just for one or two functions of service mesh, maybe just for observability, or maybe just for security. They want that mutual TLS connectivity and the encryption among their microservices. They want that rotation managed by the mesh of the certificate rotation. In this case, they no longer need to adapt the whole sidecar. With the sidecar word, right, even if you just need one function, you have to carry that luggage with your application. But with Ambient, we kind of introduce a secure overlay layer and the layer 7 processing layer, so you could adapt Ambient more gradually. So let's jump into that. For the secure overlay layer, we're introducing a per node architecture. So instead of dragging a sidecar, which is a dedicated sidecar for your application, we will provide a per node, which is a zero trust tunnel for every single application included part of Ambient on that particular node. So as you can see, instead of running the proxy, like 20 proxy in this example on the diagram, on the left side, you would just running that particular per node, the zero trust tunnel that manages all your application on that node. So this is really useful if you're just adopting layer 3, layer 4 functionality, particularly like layer 4 based traffic shifting, layer 4 based mutual TLS encryption, layer 4 based telemetry. If that fits your purpose, you could potentially just pay the cost of the zero trust tunnel and then have these functions from the service mesh. The other thing we're introducing, in addition to the layer 4 per node proxy, is a layer 7 proxy. This is an optional component in the ISTIO Ambient service mesh, only if you need layer 7 processing. So this is purposely for design to be not per node, because we want to avoid the multi-tenancy and the noise neighbor, the cost attrition problem that you could have among multiple of your tenancy. So this is more focusing on layer 7 proxy, either per service account or per your namespace, depends on whichever tenancy is your scope. So you basically don't pay the cost of that layer 7 proxy, only if you need advanced feature that's layer 7 processing. So what does this mean? So for instance, if you need layer 7 telemetry, if you need layer 7 traffic resiliency, traffic shifting, or if you need HTTP-based authorization policy that's more advanced than a basic layer 4 authorization policy. So that's when you need to start looking into the layer 7 processing layer, layer 7 proxy. Any questions so far? Yeah, the other thing I want to highlight is ISTIO Ambient service mesh doesn't mean you can't run sidecars. In fact, a sidecar will continue to stay with ISTIO. So it's very flexible. You can choose to run sidecar, or you can choose to run without sidecars, and then those applications can interoperate among them. So that's the beauty of Ambient, be able to introduced as a new data plane mode, and it's also completely compatible with the sidecar mode. So let's talk a little bit about the architecture of Ambient to visualize the zero trust tunnel. So essentially, when your application A, in this case, talks to application B, the application A traffic is going to be captured by the co-located zero trust tunnel on the same node, and then that request is going to be upgraded to be H-bone traffic, which is HTTP overlay traffic that's encapsulated request. The ztunnel is going to also impersonate based on application A, so it's going to get the key and search for application A and be able to do secure mutual TLS exchange on behalf of application A. And then on the target side, when the request is sending to application B, the target side of ztunnel is going to capture the request and then trying to do the mutual TLS exchange, trying to terminate the connection, unencrypt the request, and then forward the request to the original destination, which is application B. So you can see this very similar as a sidecar architecture. The difference, though, is the co-located ztunnel is representing multiple applications on that node, and it's also handling mutual TLS handshake for those applications representing. So that's the cost saving we were talking about, and also the flexibility and transparency we're talking about without running sidecar co-located to your application. Now, if you ever need a waypoint proxy, which is a layer 7 proxy we talk about, right? In this case, you can see the flow is expanded a little bit more, right? The traffic from the zero trust tunnel from the source side is going to send the request to the destination's waypoint proxy, and then it's going to establish mutual TLS exchange with the waypoint proxy's identity, and then the waypoint proxy is going to send the request to the original destination, which on that node, the destination ztunnel is going to capture capture the request and then do another mutual TLS exchange. So in this case, if there are any layer 7 policy, the waypoint proxy for the application D is going to be the policy enforcement point for any layer 7 policies applied for the application D. Any questions? Feel free to raise your hand if you ever have any questions. All right. So HTTP-based overlay network environment is what's being used in orange color here. The request between the zero trust tunnel to the waypoint proxy and from the waypoint proxy to the ztunnel is all through the H-bone, the protocol used to connect the nodes in Ambient. It's listening on port 15008. It's supposed to be completely transparent to your application. It's supposed to shovel your request as a byte stream and send it over this HTTP connect tunnel. And this tunnel is per service account, source and target service account connection pair. That's how we determine whether to establish a new tunnel or reusing existing tunnel. With that, I would love to show you guys a demo because demo a lot of times is much easier to explain than words. So let me start to set up my environment a little bit. So what I'm using is actually an environment powered by this third company called Instruct. They provide a hands-on experience. What they do is kind of provision a virtual machine to the cloud for me. So this is going to take a little bit over a minute. With that, I'm going to go through the demo scenario with you. So what we're going to do through the demo is we're going to we're probably going to download the ISTIO and then install ISTIO with the Ambient profile. By the way, ISTIO recently released 1.18 alpha code, which allows you to play with Ambient. And we're going to provision a Kubernetes cluster, and then we're going to, as part of the ISTIO installation on that cluster, it's a 4-node, so you'll see zero trust tunnel running on each of the node because it's deployed as a daemon set. And then we're going to spin a bunch of applications, sleep, not sleep, web API recommendation, and purchase history. And then we're going to label the namespace where these application runs with Ambient. So that means I want to include every single applications in this namespace to be part of the Ambient service mesh. And then we're going to try to run some requests from our application, like sleep to web API, doing some call. And then we're going to look at the ztunnel logs. And if the web API has a waypoint proxy, we're going to see the traffic also go through the waypoint proxy. And then we're going to apply some layer 7 policies, such as resiliency policies. Yep, I think that is the demo flow. So let me see if my environment is running. All right. So the environment is up running. This is my cluster. Can you guys see it in the back? Is the font size okay? Good? Could it be a little bit bigger? Okay. Is it better?
Yes.
All right, thanks. So the first thing we're going to do is deploy our Kubernetes cluster. Unfortunately, this is going to take a while. So basically what it does is deploy this particular 4-node cluster that we were just talking about earlier, right? So, so it's a deploy a kind cluster with 4 nodes. Now it's kind of preparing the nodes. Anybody have any questions while the kind cluster coming up? Question?
Yes. Is
Yeah.
ISTIO CTL creating the nodes? Is that what you said?
Oh, okay. Yeah, so the question is ISTIO-CTL create the nodes? That's a good question. So right now I'm not using ISTIO-CTL yet. I'm actually going to download the ISTIO-CTL very soon. So the script we're using is it's actually deploy kind clusters. So it's just using like a kind command to create clusters and say, hey, I want to be a 4-node cluster. That's about it. And after the cluster is running, I think I might set the sequence a little bit incorrectly early on. After the cluster is running, then we're going to download ISTIO Kado and then install the ambient profile. Yeah, good question. All right, any other questions? Go ahead.
So I'm kind of under the impression that kind, I could be wrong, but kind is more for like local. So are you like doing like containers that are acting as nodes on a VM?
Yeah, that's basically what we're doing. So basically we provision a pretty big VM on the cloud, and then we spin up a 4-node kind cluster on that VM in the cloud. The reason is my laptop can get really, really hot with 4-node, and also like Dock for Mac doesn't play very well on my Mac because I'm on an older version of Mac. Sometimes it just reboots for me. Yeah, and I don't want that to happen during the demo. All right, so it looks like my kind cluster is running. So if you guys want to see it, you can probably see, it's just a basic kind cluster. I have like 4 nodes, which is why kind night is deployed on 4 of them. So the next thing we're going to do is we're going to check if the cluster is ready. So it's ready. Now we're going to deploy Istio. So that's back to this gentleman's question. We're going to go ahead and download Istio, right? So I mentioned to you Istio 1.18. There's an alpha release that has the ambient support. So we've downloaded Istio, and then remember the Istio install ambient profile command we just talked about. So we're going to install Istio this way. I also added access log file configuration because I want to enable access log in case we need to look at as part of the demo. All right, so Istio, you can see it just installed Istio control plane, which is Istio D. Now it's installed the CNI, the Istio ingress gateway, now the zero trust tunnel, and now the installation is done. So basically that's just very fast. And the next thing we are going to check is we're going to look at the pods installed as part of the Istio Kado install command, right? So remember we mentioned about 4-node. So the ztunnel and Istio CNI, they're deployed as daemon set, which is why they are running on 4 of them. And then the Istio ingress gateway and the Istio D is also deployed. The other thing we're going to do is install the Kubernetes Gateway API. The reason we need to install the Kubernetes Gateway API is to deploy Waypoint proxy, which I will show a little bit later down the road. So this essentially installs 3 customer resource definition. One is the gateway class, the second is gateway, and the third one is HTTP routes. How many of you knows Kubernetes Gateway API? All right, very good. All right, then we're going to deploy our sample service. Remember we talked about earlier, we have a few sample services, sleep, web API recommendation, purchase history. We also have node sleep just to show, it's a different identity than sleep. So I'm going to create the namespace test, and then we're going to deploy the fake services, which is a fake service created by Nick Jackson from HashiCorp. So it allows you to create services on the fly using the fake services images. All right, let's check out the pods we just deployed, right? So these are the same ones I was just mentioned to you earlier. Nothing surprising, by the way, we're not running sidecar. I do want to highlight, how do you tell? It's 1/1, so that means there's no sidecar is running. So let's do some testing, right? So this is without ISTIO, right? Because this is just application in Kubernetes. Sleep as a client can call web API, right? So, and the web API calls recommendation and get a response. Recommendation also calls purchase history. So that is the sample application, what it does, right? This is all without ISTIO. Now, the next thing we're going to do is we are actually going to deploy Istio's virtual service and gateway resource. And the reason we want to do that, let me quickly review the files here. So we just did expose web API service, right? So what we're doing is we expose the web API service on the Istio ingress gateway on the port 80 with the host istioexplain.io. And when the traffic comes to this particular host on port 80, we configure routes to say, hey, let's go ahead, forward the request to this particular destination, which is webapi.test.service.cluster.local, which is our web API service in the test namespace. So now we should be able to access the web API service through the Istio ingress gateway. By the way, we're getting the gateway IP by grabbing the Istio ingress gateway's service load balancer IP. So if we hit this, we can still access our web API service, right? So this is like the most common way people adopt Istio is adopt at the edge, right? So they expose their services on Istio ingress gateway, and they're still not running any sidecar at all. All right, so let's move to the next section of my demo, which we will talk about ambient and particularly focus on how to add applications to ambient and what are the benefits you can get. All right. So the first thing we are going to do is label the namespace. Remember we talked about when you label your namespace with data plane mode ambient, that's how you include your application to ambient. And now we are going to take a pic of the CNI pod, one of the CNI pod for logs. So you can see, you know, because we added the namespace label data plane mode ambient, the Istio CNI components is going to look what are the pods within that particular namespace that has this ambient label, and let me configure the routes for these different pods. Why do we need to configure the routes? Because every outgoing and incoming traffic to these applications in ambient, we want to be captured by ztunnel first, right? So that's what these routes are for. Now the next thing we're going to do is looking at, let's see, so we're going to go through this diagram of this client, which is sleep calls web API, and web API also calls recommendation. By the way, even though web API and recommendation, if they were placed on the same node, it would still go through the local ztunnel for any policy enforcement. So that is by design, regardless whether it's the same node or on different node. So now we're going to call sleep from the test namespace and call the web API service. So we're getting a bunch of requests, which means, you know, after I added these applications to ambient, everything still works, right? So we can look at the ztunnel log and then check if ztunnel is in action, right? You can see all the inbound and outbound request is going through the ztunnel, right? The ztunnel got the connect request, and what's the duration of the request. So that's all going through the ztunnel. So exactly the same as this diagram shows, right? All the incoming and outgoing traffic are captured by the ztunnel through the IP table configuration, which are performed by ISTIO CNI, which we look at the ISTIO CNI logs early on. And then, so all the requests are mediated by the source and destination ztunnel. All right, so what does this benefit you, right, when all the requests goes to ztunnel? So the first benefit is the edge-bone tunnel, right? All the connection is going to be mutually secure. It's going to be encrypted. It's going to be identity verified. The second benefit, though, is observability. You will instantly get observability data on layer 4 observability. So what we're going to do is we're going to find out a node where Web API runs, and then we're going to get the ztunnel on that node, and then we're going to go to that ztunnel pod, and then we're going to figure out the metrics on that ztunnel. So, for example, this is getting TCP sent by total, so that's one of the metrics. So if you actually remove this, you can actually get more metrics. I believe there are 4 metrics provided by the layer 4 layer. So for instance, you can get byte sent total. You can also get connection closed total. I believe there's connection open. Yeah, so you get the idea, right? So just adding your applications to Ambient without you needing to restart your application, you instantly not only get mutual TLS, you also get layer 4 metrics. And if you were in the talk earlier, right, you could potentially hook up these metrics into your telemetry backend, then you can visualize them, and then which can become very powerful. The next thing we're going to do is authorization policy. So we're going to apply allow nothing, right? So this is best practice if you ever implement a zero trust architecture, right? You want to trust nothing and then gradually allow things that you want to enable. So basically we'll apply this policy to the test namespace to say nothing is ever going to be allowed. And then we're going to run a curl request. Now nothing works, right, because of our authorization policy. Next thing we're going to do is we know what needs to be allowed, so we're going to gradually enable those. So for instance, for Web API, we're going to allow sleep and ISTIO ingress gateway to access it. And then for recommendation, we're going to allow Web API to access it. And then for purchase history, we're going to allow recommendation to access it. So once this policy are applied, if I do another curl request, I do expect it works. Yes, that is exactly how zero trust works, right? You zeroly allow nothing, and then you gradually enable the permissions you needed, absolutely needed. Now, if we do a request from not sleep, right, because we didn't allow not sleep to access it, you actually will see an error message that the connection was reset by the target, so so the request is no longer allowed. So that is a layer 4 function provided by ISTIO Ambient through the Zero Trust tunnel. Any questions? All right, with that, we are going to go to the next demo of, we're going to talk about layer 7 processing. If you need layer 7 processing, we're going to deploy a waypoint proxy, and then we're going to show some of the layer 7 processing features. All right. I think we're going to start with authorization policies, right? So layer 4 policies are great, but sometimes you want more layer 7 authorization policy. You want more granular control of your access policy, right? Like in this case, what if you only want to allow GET requests, and you don't want to allow like delete or post or anything else, right? So that's one of the example of what layer 7 policy can provide. So let's see that in action. So let's go ahead apply our layer 7 policy, right? I'm sorry, let's go ahead deploy our waypoint proxy first. And remember early on we installed the Kubernetes Gateway API, the resources, the customer's definition, the CRD, right? So now we're using the Kubernetes Gateway resource to deploy the waypoint proxy. And this is a waypoint proxy for the Web API service account. And it's using the ISTIO waypoint as the gateway class. Remember we talked about the Edgebone listens on 15008. So that's what this waypoint is going to listen on. So let's check out the status of our waypoint. Looks like it's good. So the next thing we can do, we can check out the waypoint proxy. It's running. Now we're going to apply the authorization policy we talked about earlier on, right? So not only this time, we are only allow sleep and ISTIO ingress gateway. We're adding an operation to say we only allow the GET method, nothing else, right? So in this case, you can see we can still access the Web API from the sleep application using GET, but if we use a delete, it's not going to work. And in fact, we have a good error message, RBAC access denied, right? So that's a very good message to tell the caller, you don't have access permission. The next thing we are going to do is we're going to let's see, we're going to check the stats and premises endpoint to see what metrics we are gathering, right? The moment you deploy your waypoint proxy, not only you get layer 7 authorization policy, you also get layer 7 telemetry metrics in this example. ISTIO request load total was one of the metrics we collect for layer 7, which you can see a lot of detailed information such as your source, your destination, your principal of your source and destination, and the response code of 403, which is the one that's not allowed, and also the 200, which because we made 102, we made one successful call and one RBAC not allowed. So this matrix captures exactly what we just did. The other thing you can do is also inject fault, right? You want to make sure your application can handle timeouts. You want to make sure your application can handle network failures, right? Because with distributed cloud native applications, the network is not always reliable. And not everybody writes perfect code. So in this example, we're going to deploy a virtual service, which is a route configuration in Istio to inject some fault. Particularly, we're going to say 100% of the time, we're going to inject a 5 seconds delay when the user is Amy. And when it goes to the Web API on istioexplain.io for the host, and then when the user is not Amy, we're not going to inject this type of delay, right? Because we're only testing for a particular user. We didn't want to impact anybody else. So now if you cur istioexplain.io, which is our host, using user Amy, you are going to see 1, 2, 3, 4, 5, the 5 seconds delay, but you still get your response. So you can test your microservices and see how they handle these type of error conditions. All right, so notice what we are showing is no sidecar, right? I can still show you, all the all the applications are running without sidecar, right? So that's pretty cool. And we got all these functionalities of telemetry, layer 7 RBAC, resilience feature. Nothing we want to show is traffic shifting, right? What if you have two versions of purchase history? So we're going to deploy purchase history version 2, and then we're going to deploy a waypoint proxy for the purchase history because we want to use the waypoint to help us to do layer 7 processing on traffic shifting on the two versions of the purchase history. Now, we're going to also allow authorization policy to allow recommendation to access purchase history to config the waypoint nodes, the recommendation can access the purchase history. And last but not the least, we're going to apply the route configuration to say, hey, let's go ahead, route 90% traffic to version 1, but 10% of the traffic to version 2, so we can test the version 2 out. The ISTIO, in order to handle different subsets, you also need a simple destination rule to represent that, which we just deployed. And let's do some testing and see if it's working. So you can see we grabbed purchase history version 2. So out of 100 requests, we got 8 going to version 2, which is roughly 10%, because the way the traffic shifting works is over a longer period. It's going to be accurate since we only did 100, so 8 is pretty close to 10%. Sorry about that. Any questions?
Yes. Is the layer 7 waypoint always HTTP?
That's a great question. Yeah, so the question is the layer 7 waypoint is always HTTP, right? So that's a great question. So right now, we only handle HTTP. In the future, there are discussion of, maybe looking at, are you thinking about HTTP 2 or HTTP 3 or gRPC? What are you thinking?
Yes, gRPC.
Yeah, so we do believe actually it's probably not very well tested because the connection is coming through using HTTP 2. We do believe gRPC most likely would work, but I don't think we have an automated test to test that. And there are also discussion in the community adding support for HTTP 3 if there's some interest for that too. Yeah. Great question though. Any other questions? All right. The last demo we are going to show is we talked about earlier, right? Ambient doesn't mean we are giving up on sidecar, right? If you're comfortable with sidecar, you can continue to use sidecar. You can also gradually migrate to ambient when ambient is production ready. We're working very hard in the community to make ambient production ready, but it's not there yet. So, so what we're going to do next is to show how traffic can interoperate between sidecar and the sidecar-less with ambient, right? So I'm creating a namespace called HTTP bin, and we're going to label this namespace for ISTIO injection enable. So if you ever tried ISTIO, that's how you tell ISTIO, hey, I want sidecar injected for every single application deployed into the HTTP bin namespace. All right, so the next thing we're going to do is deploy HTTP bin. So if you're familiar with Kubernetes, so this is just deploy Kubernetes service account, and deployments. And now we should be able to see hopefully the sidecars running. So let's check that out. Yes, so you can see because of the ISTIO injection is enabled, so we inject the sidecar as the HTTP bin gets deployed. Now we should be able to send a request from sleep to HTTP bin, right? So remember, sleep was running in ambient and HTTP bin was running in sidecar, and we can still interoperate between the two. Yeah, I think that is the demo I have. Any questions? All right, the last thing I want to share is the book. I'm actually having a book signing right outside of the hall. If you're interested to understand how to get started with Ambient, what is the business value for Ambient, this is a good book to kind of help you get started so you can take some home to read. All right, thank you so much for being here. I really appreciate it.